Welcome to lecture 17, 8051 timer programming using embedded C. In this lecture, we are going to discuss timer 0 mode 3. In the previous lectures, we have discussed mode 0, mode 1, mode 2. Mode 0 13-bit timer mode, mode 1 16-bit timer mode, mode 2 8-bit auto reload, mode 3 it is a split timer mode. So mode 3 8-bit timer split mode. Here we are going to be use the timer 0 register. The timer 0 consists of 16-bit register. It consists of two 8-bit registers. One is TL0, another one is TH0. With the help of TL0, I am going to be use one 8-bit timer. With the help of TH0, I am going to generate another 8-bit timer. That's why with the help of one 16-bit timer, that is timer 0, I am going to be use the two 8-bit timer. That's why this name it call it as a 8-bit timer split mode. We are going to be split this timer 0 as one 8-bit as TL0, another 8-bit as TH0. So this is the internal circuitry of timer and the counter on 8051 microcontroller. Already you are aware of that it is a crystal oscillator. There is a inside there is a divided by 12 the network, and C slash T bar equal to 0, it is a timer. So if it is a timer, this register is going to be increment with the help of internal system clock. If C slash T bar equal to 1, it is a counter operation. It is going to be count the external event which is connected in the T0 pin. And gate control, you hope I hope you know this is gate equal to 0. You no need to worry about this INT0 pin. If it is 0, this is 1, this is 1. The TR0 just run the timer. The output becomes output of NAND gate becomes 1. So this switch is going to be closed. So it is going to be, what is that? The TL0 register is going to be increment based on whether you select a timer or counter. So here you can carefully listen. Here with the help of timer 0, the TL0 8-bit, to run this timer I am using the pin TR0 bit going to be run the timer. Once gets overflow, the TF0 is going to be set. So if it is set, it is going to be invoke interrupt. The next one, this the help of TH0, I am going to be use the one more timer, that is 8-bit timer. But what is the bit I am going to be used to run this timer? TR1. So TH0, it is the part of timer 0 register, but with the help of the TR1, so the TR1 is more relevant to timer 1 register. So here I am using TR1 bit to run this TH0 timer. So here there is only with the help of the internal system clock only I am going to be increment this one. That's why TH0 I am unable to use for counter operation. So TL0 I am going to be use either timer or else counter, but TH0 I am going to be use only the timer operation. To run this timer I am going to be use TR1 bit. Once this get overflow, TF1 bit is going to be set and invoke interrupt. But usually the interrupt will invoke with the help of TL0. Once it will get overflow, this is going to be the interrupt is going to be invoked. Suppose if you want any interrupt. The next, the operation of mode 3. The mode 3 different for timer 0 and timer 1. Now in this case we are taken the timer 0 register. It is working in mode 3. The TL0 will be used as an 8-bit timer or counter. The earlier diagram, suppose you are using the internal system clock, it will act as a timer. Suppose if you are using to count the external count, it will act as a counter. But in case of TH0, it will only act as a timer. It is going to be increment with the help of internal system clock. So that difference you must know. So that is given over here. TL0 will be used as an 8-bit timer or counter. It will be controlled by standard the timer control bits like TR0, T0, IN, T0 inputs. With the help of that, we can control this TL0 register. And TH0 is an 8-bit timer but not a counter operation. The previous slide you can able to understand this is used for only the timer operation. and controlled by timer 1 controlled bit. As already told, the timer 1, TR1 and TF1 is related to the timer 1, the register. So with the help of TR1 and TF1, it is a control bit more relevant to timer 1. With the help of this, we are going to be generate the another 8 bit, the timer, that is TH0. With the help of TH0, we are going to be use the another 8 bit timer. So this is a program mode 3 timer 0. We are using TH0 as a timer, TL0 as a counter in this case, or else TL0 as a timer, TH not as a timer, TL not as a timer also possible. But in this case I am using one register TH0 as a timer, another register act as a counter. Here as defined reg51, it is a header file. As defined counter out p1, I am going to be define entire code. That's why I taken with the help of this syntax. S bit means I am going to be use only one bit. Timer out is equal to p2 cap 1. p2 cap 1 is assigned with timer out, p1 is assigned with counter out. So void main a t mod, so 0 1. So I want to configure mode 3 timer 0. So this lower byte, it is related to timer 0. So I am going to be use mode 3. Mode 3, you have to be select M0 as 1, M1 as 1. Here the register I am going to be use as a counter. That's why definitely I make this C/T is equal to 1. So you can convert this binary into the hexadecimal number. You will get 07. That is uploaded over here. So while of 1. So here I am using the red color. So TH0, it acts as a timer. TL0, it acts as a counter. Okay, just to see how this TH0 acts as a timer and TL0 acts as a counter. Yeah, timer out, I have to be complement timer out. If it is 0, this pin is 0. After that, after some period execution of this one, it becomes 1. After execution of this time, it will going to be 0, 1, 0, it is going to be toggle. So TH0, okay, this is a time period. I am loaded in the TH0. It is going to be generate some time delay. So I want to be run the timer is equal to 1. So the while of TF1 is equal to 0 means when this the TH0 is going to be get overflow, until that the program has to be executed in the same line. Once it will get overflow, again TR1 equal to 0, TF1 is equal to 0. It is a basic timer operation. The previous the lecture you can go through the timer 0, timer 1 for mode 0, mode 1, mode 2. You can able to understand how to create the exact time delay, what about the delay calculation, everything you know. Okay, the same how to use as a timer for mode 0, mode 1, mode 2, the same operation. Now the TL0 I am going to be used as a counter. I am how TL0 initially I am loading it to 0. Again I have to be run the timer. Either it is a timer operation or counter operation, you must make this TR0 bit as 1. So counter out, whatever the external event I am counting, that is what is that incremented in the TL0. After that I want to display it on the P1, so that is counter out. Again once it will get overflow, I make this TF0 equal to 0, TR0 is equal to 0. I run this program in the while of 1. While of 1 means this is to be run infinitely. Now I am going for the Kale, the same program. Already I copy and paste over here. I hope you can how to create a project, how to set the target, how to write a program, and how to save with the dot extension, and how to add under this target. I hope all you know. The previous lecture you go through, you can able to understand. In this lecture I am going to be just discuss the mode 3, the timer 0 operation. So the same program I copy and paste over here. I am going to be compile, yeah, 0 errors, 0 warnings, and build. Next rebuild. Here just to ensure that what is the crystal oscillator frequency. Why? Because according to that only the timer is going to be generated time delay. Now I am going for the start button. Now I am going to be see the outputs. So now these things and all, just you can adjust your screen. Now the peripherals, we have port 1. By this port 1 I am going to display the count value, and port 2 I am going to be use 1 bit, that is P2 cap 1. It is going to be toggle. The timer out is equal to the complement of timer out. The next, the P3 I required because of the physical pin, the T0 here. In this pin, T0 pin, I am going to be give the clock source, or else you can physically, you can on off. This register is going to be incremented according to whatever the input you are giving. So the T0 pin, here, this is a T0 pin. I copy this one, that is the T0. This is a 3.4. if T1 means 3.5. that is a physical pin, you have to be connected externally. So now I am going for the timer. I am using timer 0. The timer 1 also had to be taken. Why? Because the timer 1 we are using the TR0 TH, the TR1 TF1 we are using, TR1 TF1 we are using. Okay. Now I am going for stepwise operation. Just you can carefully listen. Now T mod 07. So timer 0 set as the mode 3 to 8-bit timer / counter. At a time you can able to use 2 8-bit timer, or else 1 8-bit timer, another 8-bit counter if possible. Okay, that timer it is independent. It is the default. You can choose as mode 0 or mode 1 or mode 2. Now I am going for the timer 0, it complement it. Now just click P2 cap, 1, it becomes 0 complement. So TH0 it is loaded with 0xF9. So it is going to be run in the, you have to be run this TR1 I have going to be run. TR1 is going to be run to increment the TH0. Okay, that is a mode 3. No need to get confused. TH0 I have to be controlled with the help of timer 1 bit TR1. The next bit, so I am going to be increment FA, now be F9, FA, FB, FC until FF, FE. Yes. The next, it get overflow, so it becomes the TR1 I am going to be the 0, TF1 it is also going to be 0, FC. This bit becomes 0 now. Now I am going to TL0 I loaded with 00, already it is loaded. The next TR0 I am going to be make 1, then only this run will, the status, the run will show over here. Now the counter out is equal to TL0. So here the pin number 3.4, this is 3.0, 3.1, 3.2, 3.3, 3.4. I am going to be high low. So you can carefully listen the 1 count, the external count. Again high low, 2, 3, 4, 5 and so on. So it's enough, the 4 count. Again I am going to be, now whatever the count value it is 05, the 05 is shown in the port 1. Now again TF0 equal to 0, TR0 is equal to, I make it to 0. The next, now it is stop, again go for the next, here timer out I am going to be complement again. Now this is 0, now I am going to be complement. 0 becomes 1 and so on. So it is going to be count and keep on really function. So this is mode 0, timer 0. TH0 as a timer I shown, TL0 as a counter. With the help of the external event, it is going to be count. I told mode 3 is a 2 8-bit timer. So the same program here I am using the 2 8-bit timer. So TL0 I loaded with some value. I am going to be use this as a timer, and TH0 I load some values according to the time delay you want. You can load, after that you can run the timer. You can get the square wave time delay you can get with the help of TH0. Another time delay you can get with the help of TL0. Now in this program I am going to be perform the 2 8-bit timer. Now I am going to execute this program for better understanding. The previous program I just one timer, one counter operation. This program the both are the timer operation. Now I am going to be copy and paste over here. Going to be start this program. Yeah, 0 error, 0 warnings. Now I'm going to be explain this one. Here the header file, the counter out it is P1 cap 1, this timer out P2 cap 1. That is your wish. You can use timer out 1, timer out 2, you can keep, it is fine. I use two user defined function, void delay, void count. So void main T mod, this is 03. The 0x03 means what? I am using only mode 3 as a timer. I may disable this pin, it is 0. Now that's why I loaded 03. But this program I loaded with the 07. That's why one timer, one register act as a timer, the another register act as the counter. But in this case, TH0, TL0 both act as timer. That's why I loaded here. While of 1, timer out, the complement of timer out, that is 2 cap 1, and go for the delay program. It whatever the delay program I return, it is going to be executed. Again come back here. The counter out is equal to complement of the counter out. The count is the function, the delay function. Go to void count, it is going to be execute this instruction. According to that it will get delay. Now I am going for the execution of this program. I run this one. I am no need of this one. I am going to be generate two timer. So now I am going to be show how to generate the square wave. So just adjust this one. You can able to see this window setup. We go. I don't want this one. First P1 cap 1. That is the first timer. Enter it. The next P2 cap 1, that is the second timer, and close it. Here you make the P1, it is 0, 0 to 1, that is the maximum one, and again go to setup, just select P2, here also 0, 0 to 1, and just close. So 0 to 1. Now I'm going to be run it. So we are going to be generate the two square wave. Whatever the value you loaded, it is going to be what is the time delay. For example, with the help of this TH0, you are going to be generate the time delay of 0.25. With the help of TL0, you are going to be generate the time delay of 0.1. The finally, what is the output occur in the P1 cap 1 and P2 cap 1 is it has to be add this both 0.25 plus 0.1. The output becomes 0.35 with the pin number P1 cap 1 and P2 cap 1. That is the thing we are going to be obtained over here. Now I am going to be show this is here. Just I want to calculate the time period. Yeah, 0.3 millisecond, 0.30 millisecond. Now the down one also you are going to get the same time period. Yeah, 0.30 is a millisecond you are going to get. What is the thing it is? We are using the timer 0. With the help of th naught I am going to be generate the one time delay. With the help of TL naught I am going to generate another time delay. The final output going to be the combined combination of these two time period, that is occur in the P1 cap 1 pin and P2 cap 1 pin. Both the time delay and frequency is same in case of mode 3 to 8-bit timer. Thank you.